Hello guys, so what we're going to study today is about transforming the equation of a parabola from general form to work form or vertex form. But before that, let's first have a recall about the general form of equation of conic sections, specifically non-degenerate conic sections. So we know that the general form is given as ax squared plus bxy plus cy squared plus dx plus ey plus f equal to 0, where b is equal to 0. Okay, so that is the general form of equation of a non-degenerate conic section. Now for a parabola, we know that a or c is 0, but not both. So we know that a or c are coefficients of either x squared or y squared. Therefore, there should exist x squared or y squared in the equation of a parabola, but not both of them should be gone. Okay, so the general form of equation of a parabola could either be this one, ax squared plus dx plus ey plus f equal to 0, or cy squared plus dx plus ey plus f is equal to 0. So these two equations are the two possible general form of equations of a parabola. Now each of this we could transform to its vertex form. Now in dealing with the general form of equation of a parabola, we could actually have an x squared or a y squared. Okay? If we have an x squared, meaning we need to isolate y on one side of the equation. If we have a y squared, we need to isolate x in one side of the equation. Now, if we have this kind of work form or vertex form of a parabola, it actually gives us a vertical parabola, meaning our parabola could be opening upward or downward depending on the sign of the coefficient a, if it is positive or negative. Also, with this equation, it actually gives us horizontal parabola, so it depends on the sign of a, if it is positive or negative, if the graph of the parabola would be opening to the left or to the right. So let's first have an example in transforming the general form of equation of a vertical parabola. By the way, vertical parabolas are actually quadratic functions. Okay, so let's have our first example, x squared minus 6x plus 12y plus 69. So with this equation, we have x squared, so it easily gives us a hint that we need to isolate y on one side of the equation, and it will give us a vertical parabola. So let's do the first step. Let's isolate y in one side of the equation. So let's transpose it to the other side of the equation. So we'll have x squared minus 6x plus 69 equal to negative 12y. Alright, now we will group these first two terms, x squared minus 6x, because the next step that we need to do is to complete the square of this binomial. So in completing the square, we need to get the coefficient of x, and that is negative 6. Okay, and then we need to divide it by 2, so we will get negative 3, and then the answer, we need to square it, and that will give us 9, which would be the third term of our trinomial inside the parenthesis. So from x squared minus 6x, we will add positive 9 to have a perfect square trinomial, and then copy the positive 69 right here, and then we know that we added 9 inside the parenthesis, so for us not to change the value of the equation, we need to subtract 9 outside of the parenthesis, and then equal to, copy this side, negative 12y. Right? Then, since we now have a perfect square trinomial right here, we will express it as the square of a binomial. So to express it as the square of a binomial, we need to get the square root of the first term, which is x squared. So square root of x squared is x. We need to copy the sign of the middle term, that is negative, and then get the square root of 9, which is 3. Put another parenthesis and then raise it to 2. Okay, Then let's simplify the constants at this side. So 69 minus 9, it gives us positive 60, and then equal to negative 12y. Now for our next step, we need to isolate y. Thus, this negative 12 right here, we need to get rid of it. So to get rid of it, we will divide both sides of the equation by negative 12. So divide this side by negative 12, divide this by negative 12, and also divide this by negative 12. Alright, so the negative 12 right here will be cancelled, and then this one, it could be expressed as negative 1 over 12 times x minus 3 quantity squared. 60 divided by negative 12 is negative 5, and then we'll have here y. Okay, so this equation right here, we could rewrite it into its vertex form. So that is y equal to negative 1 over 12 times x minus 3 quantity raised to 2, negative 5. Okay, so this gives us now the vertex form or the work form of our parabola. Alright, so let's proceed to another example. Let's say we have y squared plus 4x plus 8y plus 16 is equal to 0. So obviously we have y squared right here, so the variable we need to isolate this time is x. So same thing as what we did earlier, we need to transpose this term to the other side of the equation. So we'll have y squared plus 8y plus 16 equal to negative 4x. And then we'll group these two terms right here, and then we'll do completing the square. So we get a coefficient of y, and then we divide it by 2, so we'll have 4. We square the answer, so we will get positive 16. And then we will add 16 inside the parentheses. So we'll have y squared plus 8y plus 16, and then copy the 16 right here, and then we know that we added 16 inside of parentheses, and we need not change the value of the equation. We cannot do that, so we need to subtract 16 outside of the parentheses, and then equal to negative 4x. Alright, then we will express this perfect square trinomial as the square of a binomial, so that will be parenthesis square root of y squared. It will give us y. Get the sign of the middle term, that is positive, and then square root of 16, that is 4, and then squared. And then simplify the constants that we have here. Positive 16 minus 16, that is actually 0, so it's fine if we won't write it anymore because it's cancelled. And then equal to negative 4x. And then we need to isolate x, thus we have to divide both sides by negative 4. So this will be cancelled, and now we can rewrite this equation as x equal to negative 1/4 times y plus 4 squared. Okay, so this is now the vertex form or work form of this equation.